This video is for Physics of the Universe, Unit 1.4, Solving Motion Problems. Today's essential question is, how do objects, such as a basketball, move in the air? Hello, baby birds. Let's begin by looking at something dynamic and real world. Parkour, especially when it's practiced in France and Japan. When an athlete leaps off a rooftop or vaults over a gap, the moment that they are airborne, gravity becomes the only force acting on them. That's why we call it projectile motion. Now, here's a little background. Parkour originated in France in the late 1980s and early 1990s, inspired by military obstacle course training and developed by a group called PotU. Their goal was efficient movement through complex environments. It later gained popularity in Japan, where it blended the urban aesthetics and discipline, creating a rich global movement. Whether you're watching someone vault a railing in Tokyo or leap between buildings in Paris, once they are airborne, the physics are universal, and that's what we will be exploring in this video. Now, think about a basketball player shooting a free throw, or someone in parkour leaping from a wall in Tokyo to another rooftop. The path that they follow is curved. It's a parabola. The shape is just like the graph of y is equal to negative x squared, which is a quadratic function. But why is it shaped like this? Because the object is moving both horizontally and vertically, and those two components interact in a very specific way, it creates this parabolic motion. So let's break down the motion step by step using the example of a basketball shot. Or you can imagine a parkour jump if you'd like. First, the athlete launches with velocity in both the horizontal and vertical directions. As they rise, or as the basketball rises, gravity slows their vertical motion. Then at the peak of the arc, vertical velocity is 0 for just a moment. After that, gravity sends them back to the way down. The horizontal motion continues at a constant speed the whole time. These two directions together create the curved arc that we're used to, whether it is a basketball sinking into a hoop or a parkour athlete landing gracefully after a vault. So here's a key concept. Horizontal and vertical motions are different. In the horizontal direction, as long as we assume that there's no air resistance, there's no force, again, just in the horizontal direction, there's no force and therefore no acceleration. The velocity just keeps going. But in the vertical direction, gravity is pulling down, causing constant acceleration of about negative 9.8 meters per second squared. That's why velocity changes in the vertical component, in the up and down direction. You slow down as you go up, stop briefly, instantaneously at the top, and then speed up as you come down. All because of gravity. One of the most misunderstood concepts. Horizontal and vertical motions are completely independent. That means that a parkour athlete jumping forward and another person dropping straight down from the same height will hit the ground at exactly the same time. Again, assuming no vertical launch speed and no air resistance. It's because the horizontal velocity only affects how far away they land, not how long they're in the air. To model projectile motion, we use different equations for the horizontal and vertical directions. In the horizontal direction, we can call it the x direction. We know that acceleration is going to be equal to 0. Therefore, velocity is constant. So my initial velocity in the x component will not change. Also, I can simply calculate the position in the horizontal direction, again in the x direction, using the simple equation x is equal to initial velocity, which will stay constant, multiplied by time. In the vertical direction, meaning the y direction, acceleration is going to be equal to negative 9.8 meters per second squared because of gravity. Here, we have to use a little bit more complicated equation for velocity. The velocity in the y direction is going to be equal to the initial velocity of the y direction, which sometimes might be 0, but if there's an initial velocity in the y direction, we're going to add that to acceleration due to gravity multiplied by time. If we're going to calculate the position in the y direction, in the vertical direction, we're going to take that initial y position, and we're going to add that to initial velocity in the y direction multiplied by time, plus 1/2 acceleration due to gravity multiplied by time squared. Now, we can assume that motion starts from the origin, meaning that original position in x is 0, original position in the y is 0. If we do this, these formulas help us calculate where a projectile or a parkour athlete will land. So let's solve a simple problem. A ball rolls off a 30-meter high cliff with a horizontal velocity, of 3 meters per second. First up, how long until it hits the ground? This is going to be an issue of time. So I'm going to use y is equal to 1/2 gt squared. In other words, y is equal to 1/2 multiplied by acceleration due to gravity multiplied by time squared. But I have to use some algebra skills to rearrange this equation to solve for t. So once I use my algebra skills, I'll have t is equal to the square root of 2y divided by acceleration due to gravity. In terms of the numbers given to us by this prompt, we have time is equal to the square root of 2 times 30 divided by 9.8. which comes out to be 2.5 seconds approximately. Part B, how far does it travel horizontally? Well, because we just solved for time, we can use the x position is equal to the velocity of the x direction multiplied by time. Again, the horizontal velocity will stay the same, and so we do not have to consider any acceleration. In part A, we solved for time, and so we can use that 2.5 seconds and plug it right in. So our displacement in the horizontal direction is going to be 3 meters per second multiplied by 2.5 seconds. Because the units of seconds cancel out, I'll have my final answer being 7.5 meters. So it hits the ground in 2.5 seconds and lands 7.5 meters away from the base, just like a parkour athlete timing their jump precisely. So here are some common misconceptions, some myths, if you will. Myth number 1, velocity increases on the way up and decreases on the way down. The truth is that vertical velocity decreases going up. It becomes 0 at the top and then increases going down. Myth number 2, launching forward makes you fall slower. The truth? Vertical motion determines the time to fall. Forward motion does not affect time. Myth number 3, acceleration changes direction. Truth? Acceleration due to gravity is always negative 9.8 meters per second squared, no matter where you are in the motion. So to sum up, our key takeaways. All projectiles follow a parabolic path. Horizontal and vertical motions are independent from one another. Gravity causes constant acceleration, negative 9.8 meters per second squared. And motion can be predicted with math. And yes, parkour athletes unconsciously use it every time they jump. At this point, you should be able to generate a full and appropriate response to today's essential question. How do objects, such as a basketball, move in the air?